All right, ladies and gents, what I want to do real quick is go through the solutions to these odd numbered electron configuration writings. We'll go through this in the conference as well, but I just want to have this available for you separate in case you guys need to go back and reference it at some point. So let's jump on to that. Electron configuration writing worksheet number 1. First thing you were asked to do was to go through the odd numbered problems at the top. Number 1 was calcium. Okay, calcium, if we look at our periodic table, has atomic number 20, which means we have 20 electrons we need to place. And if we find out where it's at, we'll see that the location of calcium is in the 1s, 2s, 3s, it's in the 4s, 1, 2, second spot in, second block of the 4s sublevel. So the configuration should end in 4s2. 4s2 should be the end of our configuration. And everything in front of that, 1s, 2s, 2p, 3s, and 3p should be filled to capacity. Let's see if that works out. And then we'll continue explaining that process here momentarily. So number 1, this is calcium. Okay, calcium, we have 20 electrons to place. So the 1s always comes first. It can hold 2 electrons. That takes us up to 2 electrons. 2s comes next. It can hold 2 electrons. 2p can hold 6. That takes us to 10 of our 20 electrons. 3s comes next. It can hold 2. 3p comes after that. It can hold an additional 6. That takes us up to 18. We have 2 electrons left. The 4s can hold both of those. We end up with 4s2. When you look at the location of an element on the table, it should tell you where the configuration ends. So we're in the 1s, 2s, 3s, 4s is where the calcium symbol is, and it is the second block in. So it's going to be 4s2 is going to end our configuration. The other way to double check is to count up all your superscripts and make sure they equal 20. So 2, 4, 10, 12, 18, 20. That is a correct configuration for calcium. Number 3 is iron. So iron is number 26. It's in the 3D, that's the 3D block, or sublevel, 3D sublevel, and it is 1, 2, 3, 4, 5, 6 spots in. 3D6 should be the end of our configuration. Everything in front of 3D should be filled to capacity. So let's see where we place these 26 electrons. Think about the filling order. 1s is where the first 2 electrons always go. Next we fill up the 2s. It's going to take 2. And then the 2p. P's can hold up to 6. So now we're at 10 of 26. 3s. That takes us to 12. 3p. 6 is what it can hold. That takes us up to 18. 4s. That takes us up to 20. We have 6 electrons left. Remember, in the 4th row is where the 3D is found. The D is always one behind the row number. So 3D, and we have 6 electrons left. 3D6. Add up your superscripts: 2, 4, 10, 12, 18, 26. 26 electrons. And we are good to go. Let's take a look at number 5, which is oxygen. Oxygen is in the 2p, and it is 1, 2, 3, 4 blocks in. So our configuration should be filled up to the 2p, and then the 2p should have 1, 2, 3, 4, 2p4 to place 8 electrons. So let's take a look at that and see what we got. So the 1s always fills first. It takes 2 of our 8. The 2s fills second. It takes 2. So we're up to 4 of our 8. After 2s comes 2p. We have 4 electrons left. All 4 of those are going to go into the 2p. And boom, we are done. Count them up. 2, 4, 8 electrons. Number 7, this is a little bit longer one. 7 is osmium. Now, osmium is down here. It's number 76. Osmium is 76. It's in the 3D, 4D, 5D, 1, 2, 3, 4, 5, 6. 5D6. So everything in front of 5D in the filling order should be full. It should be filled to capacity. So 5D should have 6 electrons in it. So let's see if we can work through that one. 76 electrons through 5D6. So 1s is going to get 2. 2s is going to get 2. 2p is going to be 6. After 2p, we go to 3s. It can hold 2. And 3p, it can hold 6. 4s, this is where your 3d comes in. Remember, d is 1 behind the row number. It'll be full with 3d10. And back out to 4p, it's going to be filled with 6. And then we're going to go 5s2. 4d will be filled with 10. 5p is going to have 6 in it. Then we're going to go 6s. It'll hold 2. This is where you have to be careful. Don't forget about the lanthanides. Your 4f can hold 14. And then your 5d has the last 6. And if you add up all of those superscripts, that'll give you your 76 electrons. If you add up all your superscripts, that'll give you your your 76 electrons. Fermium is the last one I want to go through with you. Fermium is I always have trouble finding these ones. Fermium's down here, number 100. So it is in the 5F sublevel, and it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're going to go through 5F12 on this one. 5F12 for fermium, number 100. So number 9 is FM. 5F12. So go through your filling order. 1s is going to be filled with 2. 2s is going to be full with 2. 2p is going to be filled with 6. 3s 2. 3p can hold 6. 4s can hold 2. 3d can hold 10. 4p can hold 6. 5s can hold 2. 4d holds 10. 5p holds 6. 6s holds 2. 4f is going to take 14. 5d 10. 6p 6. 7s 2. And 5f 12. So, if you add up all those superscripts, then you'll end up with 100 electrons. Okay. Last thing that I asked you to do was to go through these 2 last odds down here at the bottom. The first one, you want to figure out what element does this configuration represent. A couple different ways to do that. Add up all your superscripts, 2, 4, 10, 12, 16, 18, 28, 30. Okay. 2, 4, 10, 12, 18, 20, 32. 32. So that would be the element with 32 electrons in it, or germanium. Or we can look at the configuration and assume the Aufbau principle and Hund's rule were followed. followed. So all the sublevels were filled up correctly. And this is the address. The end is where it lives. So 4p, second element in. 2p, 3p, 4p, 1, 2, second element in, germanium either way. Number 17, 1s2, 2s2, 2p6, 3s2, 3p5, so that's 2, 4, 10, 12, 17. Number 17 would be chlorine. Or, assume the off-law principle is followed. This is the address at the very end, the last piece of the configuration, 3p5, 2p, 3p, 1, 2, 3, 4, 5 in. So germanium and chlorine were the answers for 15. All right. Hopefully, having this available will give you something to go back and check as you go through. Fundamental building block of all the other configurations that we're going to go over. So I want to make sure you guys and gals really have this down. We'll have time in class for you to ask questions, and I'll go through any of them in detail and explain any part of the process as we go through. All right, that's all for now.